Good morning, and welcome everyone to this morning's presentation. Today we are looking at SDS2 detailing. Specifically, we have put this together for those of you in India. We are early morning where I'm at. I'm from Lincoln, Nebraska in the United States, so early morning here to accommodate those of you in some different time zones. We did have a gentleman here with us local to India. However, he is having some technical difficulties on his end. Sounds like there is a power outage there where he's at. So the battery on his computer, there he is. We're trying to conserve his battery power there. So at least you can see his face. There we go. Perfect.
Welcome everyone from India.
Yes. Great to have you with us. Thank you for joining and presenting with me here today.
Thank you, David.
Since we have you, did you want to go ahead and do your introduction quick and let us know kind of who you are, and then I can kind of take it from there?
Yes, David, I would like to do that. First of all, I would like to thank SDS2. I would like to thank David for undertaking this kind of webinar wherein we are trying to reach out the local Indian audience, and they can understand more about SDS2, especially those who want to start afresh in exploring the opportunities in software SDS2. About myself, I'm selling all plant products in India, and SDS2 has been integrated with all plant recently. And so I'm also been asked to take this opportunity to represent SDS2 in India. I'm having more than 17 years of experience in different selling software, selling products, as well as selling certain engineering services. I've done my civil engineering as well as my master's in business administration in marketing from Pune University. And over last 8 years, 9 years, I'm doing business development for various engineering services and software companies in India. Especially, I've represented some companies from Scandinavia, Europe. And before that, like initial part of my career, I was doing a lot of desk-related job. Like I was doing 3D modeling and design services for US and European clients. And so I'm happy to sell SDS2 and represent SDS2 products in India. Thanks, David.
Very good.
David, also tell something about yourself. I think so. This is very short. What is written here? We want much elaborate one about yourself.
All right. Very good. Thank you. Now we know who you are. So my name is David Zabka. I've been with SDS2 for quite some time now. I started working with SDS2 in 2006. I began in our support department at that time. And so I was on the kind of front lines of support, taking phone calls, answering emails, online chats, doing technical presentations for our support department. I've made videos, I've done documentation. So a number of different things while I was in support. I also managed the support department here for a couple of years. So about 2 years, I managed the support department. And then I was involved in selling, developing, marketing a concrete and rebar product that we had for some time. So I've been on that side as well. I've done a number of roles here. My current title is a solutions engineer. So I mostly support our sales staff in doing demonstrations and helping with the technical questions that come up during a typical sales demonstration or sales process that our prospective clients may have. So, and then I do a lot of webinars along with this and technical presentations still today as well. So just to give you an idea, here's our content. Here's our agenda of what we have happening today. So we'll just quick introduction to SDS2 and Allplan. Quick overview of SDS2. We'll get into a live demonstration, and then we will take some questions here at the end, which you can enter into the questions pane on your GoToMeeting toolbar that came up when you started this webinar. So a little bit about SDS2. SDS2, we've been around, we're founded in 1981, so we've been in existence for 40 years. We've been the leading provider of steel detailing software, and we're really the only solution that incorporates connection design into our detailing solution. So one of the biggest parts to detailing is connections for your steel and your structure. So it's a very important aspect that we have built into our software. And then we kind of support a open BIM concept that we support a lot of open BIM workflows, IFC files and things like that to use for design and sharing models, construction, approval, everything from that aspect. And then we were merged with Allplan here at the first of the year, beginning this year, 2022. And for those of you who aren't familiar with Allplan, so Allplan is a global leader in BIM design for the AEC industry. They really have a heavy focus on building and infrastructure projects, and they have very strong presence in the concrete design, rebar fabrication as well. So very, very strong in that area. So a little overview of SDS2 itself and the software, some of the features. So quick overview, as far as the model input goes, it's hard for a lot of people to do the model input differently, right? So a column has 2 points for the material. There's some basic stuff on each end. So the approach that SDS2 tries to take, so this is steel detailing. We take a kind of a traditional detailing approach to our model input. So one pretty simple example of that I have up on screen here on the right-hand side is with regards to our piece marks that are assigned to each assembly or each member in the model. Traditionally, your piece marks are always indicated at the left end of that member. So as I'm looking at those members on my screen, left end is at the left for the horizontal members. It's at the bottom for the vertical members. As if I was looking at my screen from right towards the left, that would be at the left end. So no matter if you pick the points from right to left to right, we always adjust those piece marks to the left end. So one example of kind of those traditional detailing standards that we try to incorporate into our software to help with the automation and make the detailing more efficient, more accurate. Then connection design. So connection design, as you input the model, there's intelligence to recognize how the members are framing together. And then the connections are designed for code compliance, whether that be to the North American code, AISC, we have Canadian code, and a few others in there as well. So buildability, we'll talk about buildability a little bit as we design these connections. We also design for the entire joint, the entire node. Good picture of that here on the right hand side where the bottom flange is coked automatically to clear the shear plate when it's dropped in, And then also this wide flange beam framing to the wide flange column is about as wide as that column is deep. So SDS2 recognizes that, copes out those top flanges there to clear the column that it's framing to as well. And then, automation for different things like outriggers in this case. So we provide components, which are kind of parametrically driven tools. This is a really simple example of adding angle outriggers to the edge of my beam, where I specify a spacing, or could be a number of spaces in here. And based on the length of this material, this member, it goes ahead and automates that, figures that out, calculates that, and adjusts that as necessary. Oops, when we go back, so then piece marks. Piece marks are automated as well, so there's minimal management when it comes to your piece marking, and that includes every material in the project, and then every assembly or member in the project as well. So everything is compared and assigned piece marks on the fly as you build your models. And then stairs and rails. So, this is always a pain point over the last about 5 to 6 years. We've really put a lot more work into our stairs and rails within SDS2. So we have a lot more automated tools for that to help build your stairs and rails. And I think you'll like what you see there. And then our drawings. So our drawings typically require minimal cleanup. You see a pretty basic out of the box detail here. I actually used the beam that I added the outriggers to. You saw that example here on the previous slide. I just detailed that beam within SDS2 to give an example of what a detail out of the box looks like. And we do have all the tools to clean this up, add our own dimensions, adjust them, and make the changes that we have to make here. And then integration. So we integrate with all the major MRP providers, CNC providers, whether it be Petting House or some of the robotic welders that are available today, Zeman, and we also are heavily involved in BIM, so transferring models, whether that be from Revit or RISA or Tremble Connect or any number of things there. One of the things that we do really well talk about, not necessarily an integration, but something that helps with the deliverables that general contractors and project managers really like, is the way that we create our PDFs and everything is hyperlinked nice. So all that being said, let's hop into a SDS2 demonstration. I have a pretty basic SDS2 model up here and partially built, obviously, but I'm going to go ahead and continue building this off to the right here, where we see these foundations with no columns sitting on top of those. So to do that, I will open my anchor bolt plan, and you can see I've already set up grid lines. Everything's all set up there, ready to go. What I'm going to do is I'm going to overlay a PDF design drawing. Okay, so that gives me a 2D overlay of that design drawing, and I'm going to get rid of my model tree here, just minimize it on the right-hand side. And then what I'd like to do is split my modeling window, so I'll have a 3D view on the right-hand side that you can see this model built as I build it over here in the plan view. So under my members ribbon here, I have a member add column. Across the top, I get this quick add bar. So this is really good, especially as you kind of build some of these larger models and do it in kind of assembly line fashion, where we have one person who's building the stick model. Okay, so this one person building the stick model, he's maybe really just worried about getting the basic information of this member input into the model. And then there's going to be somebody who comes behind and creates or massages kind of the model and adds some of the secondary steel, like the outriggers, things like that, or adjust connections. So again, really handy for the person who is just coming in and building that stick model. So there we could see we get our columns in there very quickly. We have a base plate. This particular base plate, we don't do the base plate connection design just today, but we do set up that schedule ahead of time. And now you can see as you model, you get that base plate created, the welds, holes, everything's created there as you model your stick members. So then I'll open up another view here. I'll move up and start building my floor framing information. So I use a different reference drawing for that. And then same thing here. So now I click Add Beam. And after I pick this, sorry, I hit the wrong button. I want to make sure that I specify the correct section size up here on my quick add bar. Now, after I pick the first member, so start point and end point, left end, right end, okay, where I have identical members where the orientation is the same, the member size is the same, work point to work point length is the same, rather than always picking 2 points, I middle click at the left end of my where I want that next member to go, and it gives me an identical copy of that. Okay, and then I can model some of these vertical ones running vertical on the screen. Okay, and then we have a W18 by 35, so I'll change my section size. And I am going to model this. It indicates a W18 by 55, but I am going to model it as a W18 by 35 just for the purpose. I want to demonstrate something here in a minute. And then I'll finish this off with modeling my WT horizontal brace. So again, the quick add bar, I can specify my section size in the quick add bar. It's indicated we have this down on -6, so I'll punch that in up here in my XYZ offset, -6. That'll get that to the correct elevation for me. Okay, so now I can see, if I zoom in here, I see connections modeled as I was modeling just the main stick members, and we'll talk about what happens there in a minute as well. I want to just quickly copy these members up so that we get all the floors built here. So I'll set a selection filter to only select my beams, and then I can perform a member copy. Number of different options with member copy, and I pick a reference point, so from that beam, and I want to use my ortho command or my user coordinate system to copy that straight up in the Z direction, 12 feet. And then I can pick the end of my column to get the roof framing done on there. So a couple things that you're going to want to consider here. So we do SDS2 is, we're looking at the detailing aspect of this, but the information is in here to do a estimate as well. So if you're building a model for a fabricator for estimating purposes, we can communicate with their MRP software, whether that's Tekla EPM or Strumis or any others. We could send this information now to them to perform an estimate in that software. We could also run a tool that SDS2 itself provides. So if I circle up this area here, and maybe I don't want the concrete included in that, I want to deselect that. I just want the steel for an estimate. Okay, I have this cost estimator. You download this from our website on our SDS2 toolbox, where we provide a number of different kind of additional tools. to use within SDS2. You can run this cost estimator, set up your different costs for your material. Okay, we can set up the bolt cost based on our bolt type, bolt diameter, all that, hole cost, weld costs, everything in here. And then to make this easier to read, we can send this out to Excel and we get a basic cost estimate in here for each different material. Here's our total job material cost on the right-hand side based on what it calculated here. And then same for bolts. So each bolt diameter, bolt type, total job bolt cost that I have selected, and then cost to fabricate the holes. How much does it actually cost your fabricator to punch or drill specific types of holes? And that comes across here. And then we get a total job cost that adds everything up to give you a job total over here. So quick, basic cost estimating tools right here directly from SDS2. Okay, and then the next step that you might run into is you may need to provide a fabricator some information for ordering purposes, especially when you get maybe larger pieces of steel that are hard to get. Maybe there's more lead time on ordering those. So for that, we have easy to use ABM or advanced bill of material tools. So under my reports ribbon, I have a ABM. And I have within here specific kind of qualifiers that I can set up on what I want to assign a ABM number to. I can adjust the layout, the report layout for what needs to be included in there. And then when I'm ready, I'll create this new ABM, and I'm just going to call it 01, give it today's date. So it's March 30th, 2022. More settings as far as how I want to section off that report, rounding options, length rounding operation, or excuse me, then operation additions where I can add additional lengths to things like rolled members. And when I'm ready, have that all set up, I create that, and then I get a chance to fine tune this even more from my screen here where I can pick members on the left side and move them over here to add to the ABM. Just to make it easy for us here today, I'm going to pick everything, add everything to our ABM. I'll move that to the right side. So now this is what's going to be added to the ABM. Create that. And now I can go ahead and review that ABM. Okay, so in here we get everything is assigned a ABM ID or page and line number in this case, quantities, lengths, all that. So this is great because, the way that SDS2 works, we're really focused on the fabricator, looking at the fabricator, and we don't have to go in and make adjustments. Okay, all of our connections are designed here already. When we create that ABM, it's correct. So there's other things out there that maybe would force you to create a stick model and create your ABM before you apply connections in order to get your lengths and that correct, how the fabricator likes it. So this takes some of those steps out of it. Now, if something were to change later on, so if you recall, I input this beam here with the incorrect section size. So anytime I want to edit something, I double click and I'm going to adjust my section size now. Now this could be because of a revision or a change order or whatever, that's something about this changes. I just called it a mistake and I need to revise things here. So I adjusted that section size. I need my ABM updated. So when I hit my ABM again, I can update an ABM. Okay, so if there's additional things that were added to the model that need to be or could be added to my ABM, they would show up here and I could move them over to be added to the ABM. In this case, you'll notice down at the bottom, we have a note here telling us that there's things already on a previous ABM and they need to be updated. In this case, it's just that one change that I made. It would track all the changes and indicate to you the number of changes here that need to be updated. So I'll update the ABM. It's going to tell me it becomes revision 1. You want to continue? Yes, I do. And then when I review this ABM information, I can go back and review the original. I want to review revision 1. Okay, so now what we see here is we see a line that's highlighted, right? So we have a quantity 2. Anything that is highlighted yellow here indicates to us a change or something that was updated, revised. So we went from a quantity of 3 down to a quantity of 2 for these W18 by 35s here. That changes the total weight as well. And then down at the bottom, here we have our new size, the W18 by 55. That's highlighted yellow to indicate that revision for us as well. So pretty robust ABM tools there. Okay, moving on then. So the next thing, first kind of package for detailing that you really need to get out and submit is the anchor bolt plan, right? So I'll just come in here and select my columns. So I want to get the anchor bolts added in here to get my anchor bolt information drawings created and out. So what I do in this case, I have a anchor rod tool. So that's going to allow me just to pick my columns, and then it's going to go ahead and prompt me for my anchor bolt information. I can do straight, hook, studded, pretty robust tool here with the anchor rod member as well. Everything right now kind of out of the box, I'm just going to go ahead and accept. We can see it goes in there, finds every anchor bolt hole on these columns, and adds those anchor rods in there for me. Okay, so now then what I would want to do is I'd want to go in here to my drawings, generate my placement or erection views. So I'll hit that button there in under the drawings ribbon, and this is going to be my anchor bolt plan 99.6. Review some of my settings. We do have check boxes here to dimension the anchor bolt layout and scale that up so that the layouts are more visible for us. And while that's detailing, I'm just going to open the drawing editor, the 2D side of the program as well now. So it's going through generating that detail, and we'll open the drawing then, kind of show you what that looks like just straight out of the box here that I created. Erection views 99-6. So here we can see all my grid lines are added here, dimensioned. My anchor bolt layouts are scaled up 2 times as I had adjusted in the settings. I could create a viewport for these individual layouts as well. Don't necessarily have to rely on just that scaling up. But here we get that anchor bolt layout then, and what we do is we place it on a sheet outline, a standard kind of title block to create what we call a erection sheet. And we can see I already had that placed on there. It was just updated now with the additional information that I had placed in the right-hand side. So now we have our anchor bolt layout ready to go there. Okay, once we get that out, now we can start looking at detailing up some members and some additional functionality within there. So we talked a little bit about the connections being designed as I modeled this structure, just to kind of give an idea of what happens in here. Oops, I hit the wrong button. That's okay. So what happens here, I'm going to isolate this joint a little bit, hide the rest of my members so I can see here a little bit better. So we see the shear plates being designed here. So SDS2 has a very extensive setup or project settings. So from my home screen, I go to project settings and I can see there's a lot of different clip angle settings, there's shear plate settings. So This lets me set up, how the connections are designed. A lot of this is specific to the fabricator that you're working for. So you can set these settings up to your fabricator preferences, how they like things, whether that's material sizes, hole types, bolt settings. A lot of that's also defined by project specifications, but there's also the fabricator settings in there as well. So what we're focused on kind of is that connection. So what happens there is we have what we call auto standard connections, big table from beams to columns. So all your different framing situations are set up in here. And if I want to find the one I'm looking for, I'm a beam framing to a column. I'll scroll down and find my material types then, wide flange beam to wide flange column, web perpendicular. We can see on the right side it's showing a shear. And if we double click, we can change that, we can update that, we can adjust the different variations of the way that shear plate connections are designed here on the right hand side. You probably also noticed we have 3 bolt rows, and remember this is a W18. So the way I have this set up is I have SDS2 set up to give me what we call a minimum connections. So we can see this minimum setup connection box is checked. We see our design method within here. And then we also have the schedule of minimums for single plate shear connections. This is a table based on your nominal depth of beam, what you want the bolt diameter to be, the thickness, and the number of rows. So if we look at the W18, we can see we get 3 rows of bolts. 3 rows of bolts. If I double click this to edit this member and I look at the loads area, this is the right end of my beam. You'll notice the shear load of 49.3 kips is shown. That's the capacity of the connection as it's designed here. If I uncheck that and type in 60, when I hit tab, I'm going to get a preview. You can see that additional rows were added. So this is because now it's changing. Instead of giving me the minimum connection, what's happening is SDS2 is looking at the load that I provided. It's designing a connection to meet or exceed the capacity of this load, and then that's what I get. If I need to provide documentation to the engineers on these connections, how the software arrived at this connection design, I can use the expanded Calc button at the bottom. This gives me a PDF of all the formulas, all the information about this connection, so that engineers can review this and see how SDS2 actually designed and arrived at the result that it did. So we get basic information about our member, W18 by 35, lengths, all that. And the table of contents on the right gives us even more kind of bookmarks, easy way to navigate this, this report here. So I can go to my design strengths. We get a calculation number, unity ratio, the limit state, and the reference to the code. And then we can hit the expanded calculations, drill down even further in here to see the longhand calcs, the longhand formulas, at how it arrived at the result. So we're not only designing just that one connection, we're considering the entire joint and erectability when we do that. So if there is maybe a moment connection here framing to the flange, when I apply that welded moment, we're going to go ahead and see doublers and stiffeners that are being checked in there. And now SDS2 recognizes that. It designs that entire node, that entire joint, checks for erectability. We can't do just a simple shear connection in there now. It sees that, goes ahead and pulls that out past the flanges of this column in order to make easy erection. And then we have full control over all of these connections as well, whether that be on a material level or we can adjust the connection component to kind of come up with our own design or match what an engineer has provided the design for. So I can lock the different variables about that connection. As I change that and update that, SDS2 is still running the calculations in the background. It's just using kind of more of my design now. I'm taking control of those specific variables out of the hands of SDS2, putting those in my hands. So, okay, and then we can start to get into different kind of miscellaneous type of steel. So, you know, the outrigger example that I had shown in my PowerPoint slide, when I select members, I can add a component, gives me a list of components. Remember, we provide some of these out of the box with the install of SDS2. We also provide additional components that you can download and install on the SDS2 toolbox. I'm going to give you some more value there. So I'll add my outrigger to these two beams. You know, full control over this, which side of the beam, spacing, material types, what's the depth, number of different things in there. And it's going to adjust to the member that it's being added to. So you can see there, I added it to two beams at the same time. Even though they're different sizes, the component's reading each one to be added to, and it's adjusted dynamically to account for the different sizes. Stairs and rails. So I kind of have a little setup over here in this stair tower and a specific view to add my stairs. Now, I've done some of the layout ahead of time for time purposes, but this just demonstrates, you know, I can lay out construction lines, add my own lines in here for reference to pick points to. I can also save those off. So that's what I've done is I've saved some of those off in a file. I'm going to open that file and it pops in those new construction lines for me there real quick like. Now, I can add an individual stair in here. I'm going to use what we call our quick add stair tool. So what that allows me to do, I'm going to input my stairs from finished floor to finished floor along the nosing line of my stairs. Okay, I can input information about my stair and then my stair tower as far as the offsets and the returns on my stairs. I can do grading tread, pan tread, plate tread, all sorts of different things here as far as the tread goes. Stringer types, I can do channels, HSS, plates, number of different options there. Okay, so then once I input that basic information, all I do is pick my points up the rest of the stair tower to quickly input these stairs. And now I can see I get my stairs in here. We do have connections that are added to the stringers to the beams. Now keep in mind, these connections are not being designed as I demonstrated just a bit ago with the beams. These are just basic components that give me the materials that I need. I can double click those and adjust different settings as far as bolt sizes, rows, all that. There just currently isn't a design behind those connections. And then we provide a bunch of different tools to add the handrails as well. So for the handrails, I can use what we call add handrail to a stringer. And that's just going to allow me to pick a stringer and it reads that stringer. Based on that stringer information, it goes ahead and adds that rail. And then I can make adjustments as needed here. So maybe on this end over here, we want it to be a splice instead of a post. And on the bottom end, I want a P end, and I'm gonna just bring that out maybe 6 inches. Number of different connections here again that we can do. I'll choose a welded connection. And then I can keep going on up the stair, making adjustments to each one as I see fit. Again, kind of for time purposes, I'm not going to do all the stairs. I'll just do these first couple here and make adjustments. So this time I'm on that interior. I don't want that to extend all the way along that return. I just want it to go a little bit so that we make our turn on the interior of this stair tower. And then same thing here on that interior stringer, make my adjustments. Okay, so I'm just putting in a basic 2-pipe rail, but this could be anything from, we can use tube material, we can put pickets in there, whether they be round pickets, square pickets, tube posts, angle posts, a number of different options within the handrail. And then we also, so you can see I added these, everything I have set up is just to do a nice miter on everything. We can kind of see that interior, how that works out as well, the way that I input that. And then we have a number of different kind of what I call post-process tools. So if I need to, make an adjustment to this one rail, I have a tool in here that lets me adjust the posts on that. I can adjust the return. I can add a splice. I can move a splice. I could, move one post. So if there was one post that was troublesome, or maybe I want to move this one post here so it starts a little bit further down, whether there's a conflict with a connection, whatever it may be, I can pick the one post and then move the direction that I want to move it. Maybe I just want to move it down here, say 6 inches. I can type that, hit enter, and it moves just that one post for me. So a lot of different post-process tools, like I said. I'm just going to move that one back here, 6 inches, so it's back in its original position. A lot of post-process tools that we can do there. We even have a tool to kind of connect these rails around the landing here. In order to do that, I like to have my member ends turned on, so I can turn that on in my display options. And with this, I can continue sorry, I'm still in the previous command. I can continue the flat handrail, and what that allows me to do is I pick the 2 member ends that I want to kind of connect or continue around to. I can add my grab bar there if I need that again, and I will go ahead and do that. That way we connect everything up nice. And I should have grabbed a different connection, but this will give me a good opportunity to show you that we can go back and adjust the connection. So double click that handrail. That brings up my edit screen, similar to how a column or a beam was edited before. I can adjust this. Maybe we're going to do a shear tab, and that's going to go ahead and connect that up to the wide flange beam that I'm framing to here. Excuse me, that's a channel beam that I'm framing to there. So there we get that. Now, the next step then would be, I got my model all created, all in here nice. We need to generate some drawings from this. So I'll come back to my beams over here, and I'll grab just the one beam. Now I could detail up a whole sequence. I could detail up a bunch of members from a list. For time purposes, I'm going to create a detail just for this one beam, tell it to show me the detail. So when I do this, what happens is SDS2 reads that model, number of different settings here that I can pick and choose. So SDS2 will read the model, create the 2D drawing, add labels, add dimensions, weld symbols, everything we need for fabrication. It will go ahead and add to this detail. And So it is also going to generate a full bill of material for us here. So we can see the detail is generated pretty clean here. This is a fairly simple beam. So yes, you are going to run into some more complex situations, more complex fabrication stuff that you will need to make some adjustments to, but everything in here is pretty much kind of point and click. Click and drag. I can delete things. I can add my own information. Number of different things that I can do within here. So you're going to notice that I didn't do anything additional, and we have piece marks called out here for things such as our plate. And when I look in my bill of material, I can see that I have piece marks. So my assembly mark is assigned over here. I also have a minor mark for each individual piece of material that was created as well. These plates were identical. They didn't each get a new mark since they're identical. SDS2 knows that. As I was building the model, it's assigning piece marks as I go, so it takes a lot of that management out of creating piece marks and handling piece marks. Now the assembly marks or member marks that we see here, those are kind of temporary as they're created by SDS2. So what we do is we add these to our detail sheet to kind of create our final product. So here we can see a detail sheet that I've already created. This has some embeds on it. It transfers that bill of material information over here. And then I'm going to go ahead, I'm going to save and reuse this sheet outline. So I'll give it the next drawing name in line, S166. That gives me a blank sheet outline here. And then I can go ahead and add that beam that I just detailed to here. Fills out the bill of material, gets transferred over there properly. This is added. And then as I'm building this, I can go ahead and do another save reuse. So we go to S167. And then we have the option to change marks. I can do an auto change marks. That allows me to set up certain criteria to specify that I want done with my piece mark. You can see here, it updated the B166, maybe hard to see, but my bill of material was updated as well. If I go back into the model and open my display options to turn on member piece marks, we're going to see that's updated here as well. Any erection views that you had generated are linked and would be updated based on that new piece mark also. So easily get that mark updated. And we do have an automated tool called detail sheet auto loading to go through and load up a bunch at one time and rename them all in one shot, kind of automate that process. I'm showing you the manual process here today. So, you know, kind of some deliverables then. Once we get this in SDS2, you know, you've got to create a submittal with different exports, whether that be the CNC information, the BIM exports, send to the MRP softwares for your fabricator. We can come to the main menu, go to export, and here's where we kind of house and store all your different functions, whether it's CNC, PDF, you know, Tekla EPM. All those are kind of stored right here in one location. You can also do most of this from modeling under the import export tab also. So I'll just do it from the main menu here. And what I'm going to do is I'm going to provide a PDF submittal. Excuse me. So now in here, I can punch in all my project information, submittal numbers, add company logos to a cover sheet here, fill in information about who this is to, who this is from. If you have a Studio Bluebeam Prime account, we can upload this directly to Bluebeam Studio. I'm just going to add this and export this to my desktop to make it easy. And then at the bottom here, here's my submittal information where I'll pick my sheets. So I'm going to grab my erection sheets first. I'm going to do detail sheets next. And then I will grab all my gather sheets. And I can change this description here also. So I don't want all of that. I'm going to say, you know, material. Let's just say some middle one materials. Make it easy. And we'll call this submittal one up here. Okay, so I've got all that info. It's going to go out here to my desktop. I'll add today's date to indicate what date I submitted this. Okay, it's generating all the drawings as a PDF into this one kind of submittal package here. I left a drawing open, so it's going to tell me it can't update the last time this was plotted. Not a big deal for our purposes here. So now when I open this, I use Bluebeam here. Bluebeam's a sister company of ours, so I love to use Bluebeam. It's a great product here as well. Okay, so Bluebeam is opening up for us, and I thought that I had clicked on my submittal that I created. Let's just open it this way. There we go. So we get a cover sheet with some submittal information description. If I had filled out the to and from info, we'd get that there. And then this is bookmarked nice on the right based on my basic submittal information that I had punched in over there, so I can quickly navigate around here easily. Each page is bookmarked. And then what's really nice about this is as I look at my views, so if I come say to my S2, I have 2 erection views on here, and then I want to drill deeper into some of this information. So maybe over here, I want to find this C153. Notice as I hover that piece mark, it shows a hyperlink. That takes me directly to the PDF, to my detail sheet for this column. This works with multiple details per sheet as well, not just single detail per sheet. And then on my details, whether it be right here on the drawing or whether I look in my bill of material, the piece marks there are all hyperlinked as well. So you see, if I wanted to find info on, say, that F2, that takes me directly to the gather sheet where you can find that submaterial drawing as well. So that's our presentation today. So, you know, want to say thank you. I'm sure, you know, I don't know if Giusadine is still with us, but, you know, I'm sure he's very thankful for everybody that attended today here also. Appreciate your time. So what we have now is we will take some questions. So you can type those questions on the right-hand side in the questions pane of the GoToMeeting. As we're collecting some of those questions, we do have a couple polls to run. So just to give us some information about you as far as what detailing solution you may be using today, and then I think we have a question about, you know, what type of company that you're working for, whether that be a fabricator or a detailer, engineering firm. So it's always interesting to see who attends our webinars. So.
Yes, actually, I would also like to thank everyone, those who took out time and made it a point to attend this webinar. And thank you, David, for such a nice presentation.
All right, very good. Thank you. Thank you. So it looks like most of you are working for a detailing firm. We have a couple here probably that looks like you work for maybe a general contractor. So That's interesting to know. So we've got that poll, and then I believe our second poll that we have here is related to, sorry, not what detailing software you use, but we're pulling here what version of SDS2 you're currently running. I see we maybe made a mistake there. We don't have our 2022 version that we just released up there. So it looks like most of you are indicating version 2021, and a few of you still on version 2020. So glad to see everybody's pretty up to date on the version of SDS2 that you're running. That's good to see. So that always varies for everybody. I understand projects may run multiple years and longer, so sometimes you have to stay in a particular version. So,
are we open for any live questions if someone would like to ask something?
Yep, I'm seeing, so I'm watching the questions here. So a question here is if the drawings get updated automatically when there are changes made to the model. So it's not an automatic update. So when we do that, so you probably noticed when I created the members, I had to push detail members. So if there's a revision, we just need to go back and click that detail members again. Now, SDS2 does track what is out of date. So we flag that with a flag that we call marked for detailing. So when the model changes and now that means the drawing is out of date, there is a flag marked for detailing on that member that indicates to us that it isn't up to date. And then if it's a really small change, the user could go update the drawing themselves manually and clear that mark for detailing flag manually. Otherwise, if they detail the member again, SDS2 is going to update that accordingly based on the new model information. And there's a couple options when you detail to preserve all the user changes that you may have made previously to that. That will help reduce the rework that might happen by regenerating that detail. So yeah, looks like don't have a lot of questions here. We got the good polling information here to see what you guys are using. And I would say if there's specific technical questions that you need answered on SDS2, definitely reach out to our support team. So their email address is shown on screen here at support@sds2.com. Otherwise, when you go to our website, there is a chat feature on our website where you can chat live with them as well. So if there's specific kind of technical questions, like I said, I would definitely suggest reaching out to them for the technical questions.
David, there are still 2 open questions. If you can just spare some time to get that addressed.
So the IS code, are you familiar with the IS code, Sadine?
I'm not much, whether it is still available. We are having Indian version, but it is still in some testing phase, like whether the things are implemented properly. So I think so, Mr. Ranga Reddy sir, he wants to know like whether there is a support for IS code. Yeah.
Yep. So the question is, will SDS2 now support the IS code or the Indian code? So not currently. We're currently in kind of testing phases of that, and we hope to have that shortly. Then, correct?
A few companies in India are trying SDS2 on a trial basis. I mean, they are giving us the feedback if they find something missing or something which is not going according to the IS scopes. So I think so. It's not up to the mark now. Something is lagging.
Okay, very good, very good.
There's another question about anchor bolt.
Yeah, that one there, I would prefer to be directed to our support department. That's probably a little bit more of a technical one that
yeah,
we would be better off answering our department.
Just for the audience, I would like to make them understand. Once you log in, once you go to our website, there is a support page. There is a live chat at the bottom right of that page, wherein you can ask your questions directly. Also, you can address your question to support@sds2.com.
Yeah, very good, very good. Okay, not a lot of questions coming in here. That's okay. Here's a good question. Is there any option available for adding stringer as plate material in 2022? So maybe a little known feature of SDS2, and I believe I'm still sharing my screen, so I can actually open SDS2 again for you and show you. So this is a feature that's been in SDS2 for a long time, actually. So in my, if you want plate stringers, all I have to do is in my stair edit window, or you could do this in the quick add stair also, where we have our materials. So with SDS2, when I hit the browse button, I can't browse for plate in here. I can only browse for what's in our material files. However, any plate that I need, I can create as a plate stringer by typing in the plate description. So PL 1/2 by 12 is going to give me a 1/2 inch plate that is 12 inches width. So and again, yeah, this is a feature that it's in 2022. It's also a feature that has been in SDS2 for many versions. So this would probably go, I don't know how far back this feature goes. This has been a feature for at least 15, at least since I've worked here with SDS2 since 2006. So great question. Okay, let's go ahead. You know, if you have questions in the future, definitely you've got my email address. You have Kiyusadin's email, our support's email. We'd be happy to answer any questions that come up. Otherwise, yeah, we'll go ahead and end the webinar here today. And just once again, thank you and appreciate everybody's time. And I'm sure our paths will cross again soon.
Thank you, David. Thank you, everyone who deserted. So maybe we can wind up the webinar and end.
Yeah.
Thanks.
Yep. Absolutely.
Thanks, bye.